Question number 10 is proving that sine 3 theta is equal to 3 sine theta minus 4 sine cubed theta. So the first thing I'm going to do is I'm going to use the sum angle identity for sine to convert that to deal with that 3 theta. And I'm going to use this identity here, sine of alpha plus beta, and I'm going to make alpha 1 theta and beta 2 theta. So it's going to look like this. Sine of theta cosine of 2 theta plus cosine of theta sine of 2 theta. And then I'm also going to then use the 2 theta identity for cosine and sine to convert these. The 2 theta identity I'm going to use for cosine, I'm going to use cos theta minus cos squared minus sine squared. And the reason I chose that is because it looks like I need a sine in here. So I don't really want the cos, but I need to generate the sine. So I'm going to do this. So sine theta. And I could use any one and make it work, but this one hopefully will be a little bit easier than the others. Okay, so I'm going to replace that cos 2 theta with that expression plus cosine, and then I'm going to use that 2 theta identity for sine. So sine 2 sine theta cosine theta. Okay, so then this 2 sine 2 theta is going to generate that. And that's going to be equal to the right-hand side. Okay, so expanding this out, I'm going to end up with sine theta cos squared theta. Don't really like that cos squared theta, but I do want this sine cubed theta. Okay, and then here I'm going to end up with cos 2 cos theta, cos squared theta, and then sine theta. Okay, so we have at least generated a sine cubed here, which is good. What I want to do is maybe first of all, I want to get rid of those cosines, and I'm going to get rid of those cosines by using the Pythagorean identity. So this sine theta, the cosine becomes 1 minus sine squared theta. So I've generated another sine cubed. And then that cosine theta here becomes 1 minus sine squared theta again. And again, I have another sine cubed theta, which I'm going to need for my identity. Expanding this all out, it looks like if I just combine my like terms, I should end up with the right number of terms. So sine theta minus sine cubed theta minus sine cubed theta plus 2 sine theta minus 2 sine cubed theta. Okay, when I multiply that together, it looks like I have the right number of terms. So adding up my sine thetas, I have 3 sine theta. Then I count up my sine cubes, I'm going to have minus 4 sine cubes, and that's what I'm looking for. That equals my expression on the right-hand side.